time. That's your CT. And then they ask you for the second part. You know, they give you this, the CT. You just have to compare. I was that's why I couldn't figure out where this came from, because it's just in the tables. It's part of this. So I was just showing you where this came, this 0.5 log that equals this CT, where it came from. It actually came from a 3 log based on these parameters, but that was given to you, and this you found in the problem before. So all you have to really do is this here. Okay. I'll try to unconfuse what I confused.
Okay, so real briefly here, I just want to make sure you guys have everything here. This is a good picture, so take this picture right here. But all this stuff here is in your lab report, right? I ask you what instruments are you using, what's the program, what's the test method. This is actually a certain test method, 80-21, using the powder pillows instead of the liquid test. There's different tests. So write all that into your lab. Explain in your definition section these 3 terms. Okay, that's really important. Understand that. You don't have to write that, but you can understand that so you can really define what we're doing here. So there's 4 parts to the lab, 25% each. If you want to get 100%, then you need to get all 4 done. Okay, the first one is that all sections are complete. So all 7 sections, I believe, are on the lab report. Make sure they're all complete, which means that there's statistics involved, there's definitions involved, there's analysis involved. Okay, so just make sure you write something in all the sections that are related to the lab. Statistical analysis. In this case, we're going to use this column, tap water free, because that's the most variable. Okay, all these are pretty consistent. So use this column, do your normal statistics on this column only. Don't worry about all this stuff, just this column only. Okay. And then in your statistics, talk about why are these different? What's the reason behind that? And Dr. Thomas talked about the difference between total and free being the ammonia, right? So think about the different ammonia combinations that are in the water. Think about where the water is coming from, all those types of things. And then just discuss a little bit why this free, it looks like all the frees are a little higher than the totals, which is a little backwards, but discuss it anyway, the best you can. You won't get any points off, just to tell me something that you understand the different combinations. Number 3, the CT value. This is a biggie. This is a big part of the treatment process that we're learning here, okay? Dr. Thomas has talked about extensively and explained it very well. The CT value is concentration and time. So if you increase or decrease either concentration or time, you're going to get a different CT value. The units of CT are milligrams per liter per time. Okay, so milligrams / L times minutes. It's typically in minutes, okay? So there's concentration and time in the units. Okay, so make sure you write the units in your solution here when you're doing the lab, okay? For the CT value, you're trying to calculate what you actually got today, okay? So we're gonna use the free, the same column you did for the statistics. Use the same number, table 5, you're gonna use this number, 0.53. That'll be your concentration. So that's 0.53 milligrams per liter as chlorine. That's how that meter was reading, as chlorine, all right? So this is your units concentration. We're gonna assume 25 minutes, okay? Because if you look in your handout, this last part here talks about contact time, 25 minutes in a pipe. So since we're comparing the given information to your actual information, we're gonna use the same time. So we can compare apples to apples, okay? So you'd multiply your concentration times 25 minutes, that would be your actual CT value, okay? So once you have that, you need to get your required CT value. As Dr. Thomas had mentioned, your required it's all given here, okay? Based on the fact that this is Giardia that we're looking at, there's a 3 log reduction requirement, but we're assuming there's a 2.5 reduction credit already given through filtration and other processes. So all we're looking at is a 0.5 reduction. Okay, and that 0.5 is given as 12.3 milligrams per liter as a concentration. Okay? So you use that. Actually, that's a CT value already with the embedded time in it. That already has the 25 minutes in there. Okay, so you would compare that 12.3 milligrams per liter per minute to the number you got using your specific concentration times the time. And that ratio is what you're trying to see is either greater than or less than 1. Okay, you want it to be greater than 1, then you've met the EPA requirements. If it's less than 1, then we have it. Then there's not enough chlorine in the water, in the tap water. So hopefully all your numbers will be greater than 1. Okay? So that's this part. And then, this is really a combined question here. Once you get your ratio, compare it to the EPA requirements, and then talk about, why it should be greater than 1, that type of thing. Okay, any questions on these 4 sections of your lab report? Pretty straightforward. 1 column of data for statistics, CT value. All right, definitions, test methods. In the calibration section, how do we calibrate? Well, we didn't really calibrate, we zeroed it. So we zeroed the meter, that's what you want to put into your calibration standardization section, that we zeroed the meter for each reading. Okay, well, those types of details are important for the lab report. Any questions on this one? You guys good? Okay.